Good afternoon, students. Today I will going to discuss about KVL and KCL. Why this topic today? Because in electrical installation and estimation, before going for specification and material utilization, we need to know what are the actual parameters and what are the actual ranges we need to acquire to specify its materials and specification. So basically, what is the KVL? KVL stands for Kirchhoff voltage law. Basically, it is defined as algebraic sum of voltages in a closed loop is equal to 0. So I'll give you a small example. Let us take resistor, three resistor, one is kept in parallel with it, and two sources and two supply sources. I am keeping here the current in the opposite directions. One is in the clockwise direction and another is in the anti-clockwise direction. Here, the supply voltage I am assuming as, let us take that 10 volts, 5 volts, 2 ohms, 3 ohms and 2 ohms. Or let us assume the currents as I1 and I2. Okay, here you will be able to know how exactly KVL and KCL analysis can be done. Here, in the case of KVL, I am applying KVL analysis in the loop 1, that is nothing but A, B, C, D. So applying KVL in loop 1 means A, B, C, D. Algebraic sum of voltages in a closed loop is equal to 0. That is 10 volts is equal to 2I1 and then plus 2I1 again. Then the directions of the currents are opposite. So plus, if the directions are same, it will be minus. Therefore, 2I. The required equation now becomes as 10 volts is equal to 4I1 plus 2I2. Okay, if I am taking 2 as common, we will get as 2I1 plus I2 is equal to 5 volts. Let us take that this is your first equation. Now applying KVL in the loop 2. That is nothing but 5 volts is equal to 3I2 plus 2I2 then plus 2I1. Therefore, 5 volt is 3 plus 2. 5I2 plus 2I1. Now we are getting over here two equations, two required equations. If we simplify these two equations, we will get the individual currents as I1 and I2. By using your calculator, you can simplify with both the following equations. If you go to the equation mode in your calc, then you can able to put 2, 1 and 5 and 5, 2, 5 and 5. Will give you a required equations for or the values for the I1 and I2. So this is how KVL analysis can be done. Now I am moving forward to the KCL. In the case of KCL, it is called as Kirchhoff current law. For the case of Kirchhoff current law, it is defined as sum of current entering is equal to the sum of current leaving the node. So I'll give you some small example. Let us take that. Let's take this kind of a picture, a node over here, and let us take I1, let us take I2, I3, I4, I5, 6, 7, and 8. If you want, you can even put the values as well, but I'll give you the values as well. 1, minus 2, 3, 4. This is, let us say 6 amps. This 2, 3, and again 2 amps. So the definition says that sum of current entering to the node is equal to the sum of currents leaving the node. So here the currents which are entering to the node are I1, I2 and I3, and remaining all are leaving the nodes, that is I4, I5, I6, I7 and I8 are leaving the nodes. So I1 plus I2 plus I3 is equal to I4 plus I5 plus I6 plus I7 plus I8. Let us take that this I2 as x. Okay, I haven't specified any variable, so let us take I2 as x. We need to find it out x as I2 as the current which is entering to the node. So therefore 1 plus x plus 3 is equal to I4 4 plus 6 plus 2 plus 3 plus 2. Then x plus 4 is equal to 10, 12, 15, 17. Therefore x is equal to 17 minus 4. Therefore x is 13 amps. So the current I2 flowing in the node is, or flowing through the node is 13 amps. So now I hope you all understood the KVL and KCL analysis. This will allow or help you in calculating or finding out the room layout or the building layout values or specifications. So basically you can get the specified values. See, these are nothing but the examples which I have covered over here, that is about KVL and KCL. Through by using this type of equation or by using this type of terminology or formulas, we can able to easily identify the room layout as well as the building layout, voltages and as well as the current required to flow in each and every path or the sub-circuit. So now we go for the case of voltage division rule and current division rule. So what is voltage division rule? In the case of voltage division rule, always remember voltages when kept in parallel are same, or voltages when connected in parallel are same, but the current will differ or will change. So in the case of parallel circuit, I'll draw one simple parallel circuit for you all. This is your parallel circuit. In the case of parallel circuit, let us take, I need to calculate the voltage across this resistor and the voltage across this resistor. This is your total voltage, that is the supply voltage V. So if I want to, I'll give you some specific values. Let us take this as 20 volts voltage, 20 volts, 2 ohms, okay, 3 ohms. So there are various methods to calculate this. Basic simple method is V1 is equal to the I R1, or basically we'll go with one more simple method, that is nothing but, we know the formula that is called when the resistance are kept in parallel. So the R equivalent is nothing but R1 R2 by R1 plus R2. So what's the total equivalent resistance? Total equivalent resistance will be 2 into 3 by 5, that is 6 by 5 ohms. So that is R equivalent. Now I need to find out the total current flowing in the circuit. The total current flowing in the circuit is, therefore V is the total voltage, that is nothing but 20 volts, and R equivalent is nothing but 6 by 5 ohms. I need to calculate I. So calculate I, simple formula is there, that is nothing but V by R. V is 20 by 6 by 5, that is 5 goes up and become 100 by 6 amps. Yeah, this the current. To calculate individual drop in voltage, let us take the direction of current is like this: I, then I1 here, then I2 here. The total current, that is nothing but 100 by 6. So I need to calculate the voltage across this resistor, and to calculate the voltage across that resistor, I can also do that. That is nothing but, no, wait. Here we'll first calculate, as I said, in the case of parallel system, voltages are same. So the voltages will be same here, but the currents will be differing. So here we'll be calculating the currents, that is nothing but I1 and I2. We will not be going to calculate the voltage, we will be calculating I1 and I2. So I1 here is, that is V by, or V by, no, wait, you can also do that, but to avoid that confusion, simple way of technique I will use it. Therefore I1 is equal to voltage across this by 2. 20 by 2 I will take. 20 by 2 will not give you the current. So, here, to calculate the current I1, what exactly do we need is, we have the total current I, and we have the equivalent resistance as 6 by 5, and the total voltage of 20 volts. So one formula is there, that is nothing but I1 is equal to I into the opposite resistor, that is nothing but R2 by sum of all the resistors. And similarly we are having one more, that is for the case of I2, total current I into R1 by sum of all the resistors. So these are the equations. This is basically current division rule. Voltage division rule is applied for the case of series system, not the parallel. It just comes under the series. So where the voltages are kept different, its drop will be very short drop, and the current will remain same in the whole loop. The current will be same. So to calculate, let us take one simple example. That is R1, R2, V, this is V1, this is V2. Now I want to calculate the drop in voltage of V1 and V2. To calculate this, V1 is equal to total voltage multiplied with the same resistor by sum of all the resistors. This is the formula for calculating the drop at the resistor 1 for the required equation. Therefore V1 is equal to V into R1 by R1 plus R2, and similarly V2 is nothing but V into R2 by R1 plus R2. Okay, now let us take on some simple examples. Here all of you just make a note that for the case of parallel system, voltages will be same, but the current will be different or will changes. In the case of a series, voltage will be dropped, but the current will be same. Okay, these are the changes, these are the points which you need to keep in mind. Now let's go to the example. The example says that here I am taking a voltage of 20 volts. Just like I want to calculate across 2 ohm resistor resistor and 3 ohm resistor, V1 and V2. So to calculate V1, I need to have total voltage and the same resistor by sum of all the resistors. 5 ohms force, therefore V1 is 8 volts. Similarly, to calculate V2 is total voltage multiplied with the same resistor divided by the sum of all the resistors, right? That is 12 volts. I hope all of you have understood this concept. This concept will be related for your EIE as well. Please review this video, and have any questions, please let me know in the Canvas or in my WhatsApp. Thank you.